Okay, so last part. So looking at question number 14, we have to graph a piecewise function, which simply means I am graphing a piece of two functions. This is telling me where to draw my picket fence. So actually, I'm going to draw my picket fence in red. So I'm going to draw my picket fence at -3. This is optional. You don't have to. And if you look at my answer key posted on Canvas, I don't think I drew it in. Sometimes I do and sometimes I don't. Okay, so this first equation says we use this function if x is less than -3, which tells me that I'm going to graph this on this side. Okay, it cannot leave that side. It has to stay on that side of the yard. So for that function, which I know is a parabola, and I hope my dog does not start barking, and if she does, I'm sorry. Because she's perking her little ears up. So I know this is a parabola because it's squared. And I also know it's going to face downward because it's negative. So I'm going to make my T-chart. I'm going to start my chart at -3. And remember, I have to use these numbers. So I'm going to stick pretty close to the fence and do -4 and -5. All right, so take a moment using your order of operations. Substitute each one of these numbers into the function to find your y values. Now, I have already done that, so feel free to pause the video and then come back and check to see if you have the same values that I got. Okay, so this is what I got. Okay, this first one, notice it's not equal. So that tells me that this very first point, which is on the fence, is going to be open. So I'm going to put an open circle, -3 down 2, open circle, -4 down 1, -5 down 2. And if you want, you can add as many points as you need. There really isn't a maximum number of points. Now, because I know that this is a parabola and that this graph is going to hit the vertex and then fall back down, I really don't need any other points. But you could. All right, so now let's look at my second one. Take this away. Oops. Okay, I didn't mean to do that. Okay, so now let's look at the second equation. Well, this one is very easy to graph because it's just a horizontal line. So what this is saying is that y will always be 5. Y is always 5. So if you were to make a chart, the only number you can put for y is 5. Starting with x is -3. And again, using these numbers on this side of my red fence, y will always be 5. Now, this first point is actually equal to, so I can make a close point. So I'm going to put a close point here, and then just draw a ray going to the right and my graph. The main thing to keep in mind, don't add arrows. Okay, we can't do this because 2 reasons. Number one, it would fail the vertical line test, which means it's not a function. But most importantly, they have to play on their side of the yard. And for the 5, for the second function, it has to be over here. All right, so now let's look at question 15. 15 is a little bit more complicated because there's two fences. I'm going to put a fence down at -2. And I also have a fence at +4. So now we have 3 functions sharing the playground. So let's start with the first one. This one is an absolute value. And this function can only be, okay. This function can only be on this side. Okay, so it's going to be the absolute value of x plus 3 minus 1. So when I make my t-chart, and we've practiced this quite a bit, I'm going to start it at -2. And again, I'm choosing these numbers. So I'm going to use -2, -3, and -4. Go ahead and pause the video. See what you get for your 3 y values. And then we can come back and see if we agree. Okay, so I got a 0, a -1, and a 0. And this is not equal, so it's open. So -2, 0, -3, down 1, -4, 0. So this is a V. Okay. And that would be that piece. All right, so now let's look at my middle piece. Middle piece, we'll do that one in blue. That is just a straight line. And that straight line doesn't have that much space. It has to stay right here. So this second graph can't leave this part of the courtyard. Okay, so again, let me make sure. I think maybe if I color code this a little bit better. So this, that's for my first one. The second one has to be in here. All right, so let's go ahead and graph it. So when I graph it, I'm going to start by putting my endpoints because this is going to be a segment. We have a start and we have an end. So let's start off by putting in -2 and +4. And I think it's pretty easy to put in 0. So this should go pretty fast. Take a moment and substitute in those 3 numbers. Come back and see if we agree. So for this first one, I have 2 times -2, which is -4. -4 minus 3 is -7. 2 times 0 is 0. 0 minus 3 is -3. 2 times 4 is 8. 8 minus 3 is 5. Both of these are equal. So all of my points here will be closed. All right, so let's go ahead and graph it. So -2 up 7. And then I have 0. Oops, sorry. Let me go back. -2 down 7. And then I have 0, -3. And then I have 4, 5. Okay. Bear with me. Trying to make straight lines. On my iPad sometimes it's a challenge. So there we go. All right. Kind of out of space. So let me extend my little page here. And let's switch to purple for this last one here, which is our square root. So when we do our square root, we have a domain restriction. And my domain restriction says that I have to use numbers greater than or equal to 4. But this is saying only greater than 4. So I'm going to pick numbers that I know won't give me a decimal. But remember, you do you. You can use any number over here that you feel like you want to use. I am going to try to make it a little easier on myself and pick numbers that I know will give me a perfect square. So I am choosing 4, 5, and 8. Okay, 4 minus 4 is 0. The square root of 0 is 0, and 0 plus 2 is 2. 5 minus 4 is 1. The square root of 1 is 1, and 1 plus 2 is 3. 8 minus 4 is 4. The square root of 4 is 2, and 2 plus 2 is 4. And this one, again, open. Okay, so let's graph it. Okay, so at the 4, I'm going to go up 2, open circle, 5 up 3, and then 8 up 4. So it's going to look something like that. Again, every function is on its own little piece. We don't share. We can't share. That's the main thing. Also notice that every function is touching a fence. So this one is touching the fence. The one in the middle has to touch both fences. And the one at the end touches the fence on the far right and goes towards infinity. Okay, so now let's talk about evaluating. So we don't have to graph it. We're just going to evaluate it. So what I have is a number line. Okay, negative infinity to infinity. And I'm going to break it apart at negative 2 and 4. So at negative 2 and 4. And just like in the last graph, I have 3 different functions. So this function is for this piece. Okay, so if I have a number that is less than negative 2, then I'm going to substitute it into the negative 5x plus 4 function. And then I have this one, which is for the middle. So if there's a number between negative 2 and 4, then my answer is simply negative 3. And then lastly, I have this one, which is x cubed to the power of 5. And I use that one when I have numbers in the domain that fall here. All right, so let's start off with this one, negative 3. Where does negative 3 fall on my number line? Well, negative 3 is actually going to be less than negative 2. So that means that I am going to use my negative 5x plus 4. You're only substituting these numbers into one function, but you need to figure out what is the function. What function has control over that number? Negative 3 falls over here. So that would be negative 5x plus 4. So I have negative. Excuse me. Sorry, I tried to hold it in, but I couldn't. Okay, so I have negative 5 times negative 3 plus 4. And when I type that in my calculator, I get, I definitely need to fix that. Okay. I get 19. That would be my answer. All right, negative 2. Notice negative 2 is right here. So it could be purple, it could be pink. How do I know? Well, I need to look here at the rule. Notice that the equal sign for the negative 2 is in the pink, not the purple. So negative 2 belongs to my middle piece. And the answer is just 3 or negative 3. No calculator needed. C, where is 5 on my number line? Well, 5 is greater than 4, which means this is my function. So that would be 5 to the power of 3 plus 5. Again, feel free to always pause the video at any time. And I got 130. And then lastly, 0. Well, 0, again, falls between -2 and 4. So my answer is -3. All right, let's do one more. Let's look at number 17. So I have my number line again. And then I have -3. And I have +3. Okay. So we got this one. That's the less than. So that would be here. And then I have this one, which is in the middle. And then I have this one, which is on the far right. So I got to figure out which function am I using. Okay, so this is just the absolute value of 2x minus 1. This one is -3 times x plus 1 squared. And this is a 1/3 x plus 4. Okay. So we got 3. Both of these numbers are on the fence. We got to figure out who owns that fence. -3. -3 is owned by the blue family. Because see how it says -3? It can equal. It can't equal for the purple family, but it can equal for the blue family. -3. So that means that for question B, I'm going to use my blue. So I'm going to actually highlight it in blue because it belongs to that family. The +3, all right, who owns this fence? It's either the blue family or the pink family. And I know I did that out of order. Okay, so who owns this fence? It's either the blue family or the pink family. Well, let's look at the rule. Here, see how it says that the pink family can equal 3? So that tells me that I'm going to use the pink function for part A. All right, I'm going to encourage you to pause the video at this time and try to work through C, A, B, C, and D and see if we get the same answer. Okay. So for part A, I got 5 because, again, that goes with the pink family. 1/3 times 3 is 1, and 1 plus 4 is 5. Here, the -3 went into my quadratic, and I came out with -12. -7, you should say, belongs to the purple family. So that means I'm going to take the absolute value of 2 times -7 minus 1. Okay, 2 times -7 is -14. -14 minus 1 is -15. And the absolute value of -15 is +15. 0 is owned by the blue family. See, 0 falls on their land. So I'm going to use this one. So that would be -3, 0 plus 1 squared. So that would be 0 plus 1 is 1. 1 squared is 1. -3 times 1 is -3. Okay. Last thing is question 18. We made it to the end. So remember, domain, we read the graph from left to right. Okay, so left to right, I'm going from here to here. So my domain is -4 to 6. Okay. Brackets. Range. My range, let's see, how low does this graph go? It comes here to here. So that means it's -2 to +3. Okay. This is asking you, what is the y value when x is 6? That's the question you need to answer. What is the y value when x is 6? Whenever there's a number inside of the parentheses, what is the y value when x is 6? When x is 6, y is 0, so my answer is 0. For what value does y equal 1? Well, for that question, I'm actually going to draw a horizontal line at y equals 1. So if I draw a horizontal line at y equals 1, that red line is crossing here, here, and here. So I would say that my answers are x equals -2. This one is a little bit greater than 4. It's not quite 5, so I'm going to say that this point here is 4.5. And I'm going to call this one 5.5. So 4.5, 5.5. We have to approximate those last two, because again, I'm trying to figure out what are my x values here and here. All right, for what values, state the values where the graph is increasing. Okay, so where is the graph increasing? Well, it's actually only increasing for a very short amount of time, and that's from here to here. And remember, we focus on x, not y. So it's increasing from 2 to 5. Please, no brackets. When we're talking about increasing and decreasing, no brackets. Brackets are only used for domain or range. So where does it decrease? It decreases twice. It's decreasing from here to here, which would be -4 to 2. So that's the first point. -4 to 2. And then it starts to increase for a short amount of time. And then it decreases again here from 5 to 6. All right, and that is the end of our Chapter 2 test review. I hope this helped.